Okay, so the sum and difference identities, understand that this here is only for cosine function. And then we will also be going over the sine function today. But so in order to find out what the cosine of 7 pi over 12 is, we're going to have to write 7 pi over 12 as a sum. So if you think about, or it could be a difference. In this case, it's going to be a sum. What adds to be 7? I have 3 pi over 12 and 4 pi over 12. Now I'm using 3 and 4 because 3 pi over 12 will reduce to 1 pi over 4, and 4 pi over 12 will reduce to pi over 3. Once I have those, I have my A and my B. So now I can go ahead and plug it into this formula here. Cosine of A times cosine of B. I'm going to have to change some. Okay, I had to make the problems a little smaller so I could fit it in. So cosine of A times cosine of B minus sine of A times sine of B. And I wanted these to be ones from the unit circle that I can find the trig function of. Remember the unit circle? I'm going to be using pi over 4 in this one. And remember, my coordinate there is square root of 2 over 2 and square root of 2 over 2. The cosine is the x value, so that becomes square root of 2 over 2. The cosine of pi over 3, remember pi over 3 is here. And this is the one that's going to be a little tricky to figure out which one goes first, the 1/2 or the square root of 3 over 2. And what's first, what's the x in this one is the 1/2. The y is square root of 3 over 2. So when I do cosine of pi over 3, that's going to be 1/2 minus sine of pi over 4, square root of 2 over 2. Sine of pi over 3 is my y value, square root of 3 over 2. And now I can multiply, and that's going to be square root of 2 over 4 minus square root of 6 over 4. And now I can combine them, square root of 2 minus square root of 6 over 4. Nothing else can be simplified there. I can't combine the 2 and the 6. I can't reduce, so that's my simplified form. And so when I have the cosine of 15 degrees, I'm going to do the same thing. I'm going to think of 2 degrees that add or subtract to be 15, but I can't use 10 and 5 because I don't know what the cosine of 10 is or the sine of 10. I don't know what the cosine of 5 is or the sine of 5, but I can use the ones that I know. I have 45 minus 30, and that would be okay. So that means my A is 45, my B is 30. And this time, because it's a minus, I'm going to be plugging it into this second formula. So I have cosine of 45 degrees times cosine of 30 degrees. And this time it's a plus sine of 45 degrees times sine of 30 degrees. And now I can again use my unit circle. I'm looking at first quadrant. 45 degrees is square root of 2 over 2 for both of them. So that's going to be my x value, square root of 2 over 2. My x value of the 30 degrees, that's my longer x. The x is my longer side for that one. So that's square root of 3 over 2 plus square root of 2 over 2 times the y value on this 30. The sine of 30 is 1/2. So I get square root of 6 over 2 plus, square root of 6 over 4 plus square root of 2 over 4. And now my common denominators are the same. Square root of 6 plus square root of 2 over 4. Okay, in this one, the directions are to write as a single cosine function. And so basically they gave me the right side of the identity, and I need to change it to the left side. Well, first, if you notice, this is the sines first and then the cosines. So I'm going to switch that. Cosine of 5x times cosine of 2x plus sine of 5x times sine of 2x. And so my a is equal to 5x, my b is equal to 2x, and so this is going to be equal to the cosine of 5x minus 2x, so it's cosine of 3x. Go ahead and pause it and you try the next one, and then I'll give you the answer in 5 seconds. And so the answer is cosine of 4x. And I have cosine of x plus 3x. So these are the identities for sine. And notice they are different. This time I have sine times cosine. And this is sine of A times cosine of B. And then the next one is cosine of A and sine of B. Also notice this is a plus here and a plus here, where in the cosine they were the opposites. So when I have 5 pi over 12, I have to use either a sum or difference of 2 in order to get that. So I can use 3 pi and 2 pi, 3 pi over 12 and 2 pi over 12, and add them together, and that would be 5 pi over 12. So I can reduce those, and that's pi over 4 plus pi over 6. And now I can write it in using the formula, and I have sine of A, well that's pi over 4, times cosine of B, that's pi over 6, plus cosine of A, pi over 4, times sine of B, pi over 6. Sine of pi over 4, well pi over 4 is square root of 2 over 2. The y value is square root of 2 over 2. My x value of pi over 6 is square root of 3 over 2 plus square root of 2 over 2. And my y value of pi over 6 is 1/2. So I have square root of 6 over 4 plus square root of 2 over 4, which is equal to square root of 6 plus square root of 2 all over 4. When I'm doing the sine of 75, I can split that into the sine of 30 plus 45. and that's going to change to sine of 30 times cosine of 45 plus cosine of 30 times sine of 45. Sine of 30, my y value of 30 degrees is 1/2 times square root of 2 over 2 plus x value of 30 degrees is square root of 3 over 2 times sine of 45, which is square root of 2 over 2. So I have square root of 2 over 4, plus square root of 6 over 4 is equal to square root of 2 plus square root of 6 over 4. And this actually is the same as the one before, because 30 degrees and 45 degrees are the same as pi over 4 and pi over 6. This is the last one, and in this one I'm going to be asked to write as a single sign. But if you notice here, I have this 3 in the front here and the 3 in the front here. Without that, I would be able to have my A and my B, but with those 3 that are in the front, it kind of makes it a little difficult. So what I'm going to do is I'm going to factor that out. So when I factor it out, I have 3 times sine of x cosine of 3x plus, and then I have cosine of x times sine of 3x. My a is x, my b is 3x. I still have the 3 out in front, so it's 3. This is the sine, so 3 times sine of x plus 3x. This is going to be 3 times sine of 4x. And that's all. Check the website for the assignment.